All right, so now we go into the theory of music that has to do with chords, harmony. All right, some notes together sound great, while others don't. And the first person to really explore this was Pythagoras. Okay, and that's again why he's called sometimes called the father of music theory, not just a mathematician. Okay, so two tones are called harmonious if they sound good together. Okay, and I can sort of demonstrate for you what sounds good together and what doesn't. Okay, but it turns out this is one of the great discoveries by Pythagoras. The two tones harmonize together if the ratio of their frequencies is a simple fraction. So this is how closely mathematics is related to music. That which sounds, good to our ears can be explained using mathematics, basically the frequency. All right, now, so over here, I deliberately did not fill all these details here because it would have taken a lot of time, but I put key elements in here. Like for instance, I started with C, I have E, I have F, I have G, and I have A, because these are the important numbers, okay, in the scale of C or C major, C minor, well, C major, yeah. Okay, so compare, for instance, C and E, right? So the ratio, what's the ratio between the frequency of E and the frequency of C? The answer is, because this is irrational, the answer is going to be not exactly precise, all right? But let me show you what we mean by that. 327.58, that's an approximate number, divided by 260. That would be the ratio of the frequency of E and the frequency of C, okay? And it turns out to be about 1.259, but it's fairly close to, okay, approximately close to 1.25, right? And 1.25 is 5/4. Okay, if you divide 5 by 4, you get 1.25, which is a number fairly close to the ratio between the frequency of E and that of C. Okay, we have a name for this. Okay, so let me sketch this really quickly. Okay, so I've drawn this very quickly here. C is our base here, and that's the first note in the C scale. And what we have just done is to compare the frequency of E and C, right? The ratio between the frequency of E and the frequency of C happens to be close to 1.25, and that is a simple fraction, 5/4. Not exactly, but it's approximately equal to that, right? So they harmonize well. And in fact, if you play the chord C, the C chord consists of C, E, and G. Okay, so these harmonize well. These are consonant sound. And C and E, this interval is called a major third. Now, I'm not going to ask you about this because this really belongs to the music theory class, right? But the interval between C and E is called a major third, okay? Sort of like D and F sharp, same idea. All right, C and F, okay? So let's compare the frequency of C and the frequency of F. You always divide the higher number by a lower number, okay? And here, this will be very close to 1.33 and whatever. Okay, this is very close to 4/3. Okay, in fact, it's really, really, really close. Okay, much closer than this number was to 1.25. And so, in fact, you can sort of tune your instruments together in such a way that C and F are exactly 4/3. Okay, if that happens, C and F will sound really, really cool together because the ratio of the frequency is so simple, 4/3. Okay, so that would be C and F. And because F is the fourth note in the C scale, and if this is perfectly 4/3, this is called the perfect fourth. Okay, so the F is called the perfect fourth above C in the level, in the key of C. All right, C and G, this is probably the most well-known one. That's 389. Now, by the way, these numbers come from the chart we just described here on page 1, right? And so 389.56, if you divide this by 260, you get 1.498, which is almost precisely 1.5, which is 3/2. Okay, now you can't really get simpler than this. except maybe 2, right? That's 1.5. And so this is also very close to the correct number. And you can tune your instruments in such a way that the G is exactly 1.5 or 50% higher than C. And in that case, you would be calling that perfect fifth. So the perfect fifth note in C of in the scale of, or in the key of C, is the G sound. All right. And so this is called the perfect fifth. And then how about A? So this will be this A here. And if you divide 437.27 divided by 260, you get something like 1.6818, not very close, but it is fairly close to 1.66, which is 5/3. Okay. And so this is because it's a sixth note in the scale and in the key of C. This is called the major sixth sound. Okay, and there's a minor sixth, which is A flat. Okay, and then if you go from C to the next C, that would be, of course, by the definition of an octave, this is exactly 2, and so that is an octave. Okay, so these are the words that would describe what we call the intervals, okay, in a particular key. And so these are all just structured in a mathematical way, in a very ratio-based way. And these will determine what sound will go better with this. If you look at, for instance, C and F sharp, I don't have the number for F sharp here, but if you do C and F sharp, you can find the ratio is nowhere near these simple fractions, okay? And so if you cannot describe a ratio as a number close to a simple fraction, they just don't sound good, okay? And so you can tell that they do not sound good together. Maybe I can demonstrate that for you in just a second. Okay, so what sounds harmonious and what doesn't? All right, C and E, as we saw, C and E is called major third. See, this is C, this is E. Sounds good, right? How about perfect fourth, C and F? Yeah, so, you know, sounds like the beginning of a song, right? All right, so that sounds good. Perfect fourth. Perfect fifth is C and G. Okay, so again, if you're a music major, you know these things. Very, very basic ideas, right? So the perfect fifth sounds very good, right? How about major sixth? It's C and A. Okay, so that's pretty good. And then the octave, C to C. You know, these are the first 2 notes of what is that? Somewhere over the rainbow. Yeah, okay. So they sound good. What doesn't sound good? I told you C and F sharp, okay? Tritone is what's called, and they don't sound good because the ratio of their frequency is nowhere near a simple fraction. And this is what it sounds like. Now you can use that to, you know, dramatize something, to make things dramatic, like, you know. But I mean, this, and again, musicians know these things, right? And so they know that certain tones work together to make a harmonious sound. And so that is what you can learn. It's really all based on mathematical, you know, the rational numbers. Okay, now continuing on in the key of D, G is the, again, the ratio is 4/3, and so this is perfect fourth. So the perfect fourth changes. Perfect fourth used to be an F in the key of C, but now in the key of D, the perfect fourth is actually G, right? D and A, if you divide this number by that number, you get something close to 3/2, and so A is the perfect fifth in the key of D, right? And so again, this is a fairly complicated thing, right? The musical structure is a mathematical structure, and it's governed by the laws of mathematics, and it is fairly complicated. That's why sometimes people say people who are good at mathematics can learn music theory quite well. All right, but none of these ratios are exact, okay? So note that these ratios are not exact, okay? Now you could do that. In fact, you could make C and G to be just perfectly in the ratio of 3/2. And you can use that fifth, okay? And then you can go to the next fifth from G to D and so on. And in that way, you can just make the your entire instrument to be tuned to to that particular perfect fifth and so on. But then the problem is, then things get messed up if you use a different key to play, play a different piece of music in a different key. And so they need to come up with a compromise. And they did make the compromise by using that irrational number that I talked about. Okay, and using this irrational number, everything works out nicely, but you lose the exactness of these fractions. This is called temperament or tempered scale, temperament. And there have been books written about how to tune your piano, for instance, in tempered scale and so on. This is just a little small adjustment so that you can play any song in any key and make it sound good by just one instrument, such as piano, but they have to use the tempered scale to make that work. All right, finally, before we go into fractals, let me make a quick comment or comments about major and minor chords. I personally find it fascinating. You know that some pieces of music are written with in major key and some of them in minor key. Typically speaking, people associate the major key as a happy sound, happy song, and the minor one as either serious or sad sound. Okay, so what's the difference between the major chord and the minor chord? C major, for instance, consists of C, E, and G. I'm talking about the C major as a chord. C minor, something happens. Okay, it's actually flat, right? So you use E flat, but the other two notes are the same. Okay, the same thing with D major is D, and then F sharp and A. Okay. Again, if you're a guitarist or if you play music or if you're a music student, you probably know these things like backwards, like the back of your hand. D minor, what's the difference? The only difference is what used to be a sharp is now natural. And so the difference between, okay, let me go ahead and write the difference. The difference between the major chord and the minor chord is out of the three notes you played, only the middle one changes, and not by much. Okay, the middle note is half a step lower. That's it. Okay, so notice here, I'm D, F sharp, A just becomes D, F, and A. All right, and the sound difference is incredible. Right, just by this difference, which is the middle note, that moves half step down to make a minor key. All right, and so what is half step off again? That's the ratio of 5.9463%. Right. Again, this is the only difference, and this difference only happens in one of the three notes you play in a chord, and that small difference makes all kinds of difference in the world when you listen to music, and we all can we all can appreciate the difference. All right, so listen, just a little, just listen, just for a few seconds here. Okay, so you can sort of hear the sound, that's a pretty happy sound. Okay, I'm playing D major, but if you play D minor, so you make that F sharp into F, then it sounds very different. So this D major becomes D minor, okay? D major, D minor, okay? And you can do the same thing with A major. Here's A major, sounds pretty happy. A minor. Okay, what's the difference? I'm telling you, the difference is that one note, okay, namely, in this case, it's C sharp becomes C, okay? The only difference is that the one of the three notes, the middle note, is off by 5.9463%. Becomes from this to this, or from this to this, right? So it really changes the mood, but not because of a drastic difference. It's only a tiny difference by 5.9%. And I find this pretty amazing because that slight difference changes the entire mood of the music, okay? So that's the difference between the major and minor chords.